Hello everyone. Today I will be discussing our research on the impacts of BERT-infused deep learning models on sentiment analysis accuracy in financial news. As we know, sentiment analysis is crucial in financial decision making, where understanding the underlying sentiments of news can be greatly impact market prediction, and investment of strategies. In this study, we focus on improving the accuracy of sentiments classification by integrating the advanced natural language processing capabilities of BERT with the traditional deep learning models like LSTM, GRU, and CNN. Our finding demonstrates significant improvements in model performance, which I will share with you through this presentation. So this work is made by me, Oussama and Ndama, in collaboration with my colleagues Ismail, Bensassi, and the Dr. Mokhtar En-naimi from FST of Tangier, Abdelmalik Sadi University of Tetouan. Moving to the introduction, in today's fast-paced financial world, the sheer volume of online news and media reports poses a challenge for investors and analysts. While this information is crucial for making informed decisions, manually analyzing sentiments in real time is almost impossible. This is where sentiment analysis come in, providing a way to automatically evaluate whether the tone of a financial news article is positive, negative, or neutral. However, traditional sentiment analysis models often struggle with the complexity or subtlety of financial language. Our study addresses this gap by incorporating BERT, a powerful NLP model, into deep learning architecture to better capture the context and the nuance of financial text. This integration allows us to significantly enhance the accuracy and depth of sentiment analysis. Why BERT? BERT stands for bidirectional encoder representation from transformers, has transformed the way we process language in NLP tasks. Unlike older models that only process text sequentially, BERT looks at the context of a word from both directions, left to right and right to left, giving it more complete understanding of the meaning in a sentence. This makes BERTs especially effective for analyzing the intricate and often ambiguous language in financial news. In our research, we leverage BERT's ability to generate deep contextual embedding, which allows the model to more accurately understand the sentiment in the news article. When integrated with deep learning models, BERT helps capture the complexity of financial sentiments that traditional models might miss. Moving to the methodology, our research methodology follows a structured approach that began with data preprocessing and end with evaluation of several deep learning models, both with or without BERT. So, first, we compiled a dataset of financial news from major news sources such as SNBC, The Guardian, and Reuters, covering a span of 3 years from 2017 and 2020. After cleaning and preparing the data, we apply sentiment polarity analysis to label the article as a positive, negative, or neutral. Then we implemented several deep learning architectures, including artificial neural networks, long short-term memory, gated recurrent units, and convolutional neural networks to analyze sentiments. For each model, we ran experiments both with or and without integrating BERT embedding, which allow us to compare the performance improved brought by BERT. Data preprocessing as a critical first step in our methodology. We began by collecting a diverse data sets from 2017 to 2020, pulling articles from financial news sources like CBNC, The Guardian, and Reuters, which provided coverage of varying market conditions. The next step was the cleaning of the data. This included standardizing the text by converting it in lowercase, removing punctuations, stop words, and duplicates, and performing lemmatization to reduce words to their base form. Once the dataset was cleaned, we performed a polarity analysis using the Vader sentiment analysis tool, which assigned each article as a sentiment score ranging from -1 for a higher negativity sentiment to +1 for a higher positivity sentiment. This, to, this preprocessing step ensured the quality and integrity of the datasets, setting a strong foundation for building our deep learning model. Moving to our model architecture, after preprocessing, we built several deep learning models to perform sentiments classification. We use four main types of models: ANN, LSTM, JRU, and CNN. Each of these models has its own strength. For example, LSTMs and JRUs are particularly good at understanding sequences of the text, which is important for capturing the flow of information in news articles. CNNs, on the other hand, excel at identifying key features and patterns in text. Once this baseline model were developed, we enhanced them by integrating BERT embedding. The BERT model, pre-trained on a massive corpus of text, provide deep contextual understanding of each word in the article. By combining the strength of BERT with these deep learning models, we significantly improved the accuracy of our sentiment analysis. We see here the results. This is the results of our deep learning models before infusing BERTs and those after infusing BERTs. So our results show a substantial improvements in accuracy when BERT is integrated with the traditional deep learning model. For example, the accuracy of LSTM models increased from 94.17 without BERT to 96.74 with BERT. Similarly to JRU model, which achieved a baseline accuracy of 95.20 before, and after that it raised to 97.02 with BERT. These improvements highlight the power of BERT's contextual embedding in enhancing sentiments classification. The model BERT-JRU performed the best overall, achieving an accuracy of 97.02 along with a high precision and recall and F1 score. This demonstrates the transformative impact of incorporating BERTs into traditional model, especially when working with complex domain-specific language like that's found in financial news. To conclude, our research demonstrates the effectiveness of integrating BERT with traditional deep learning models for sentiment analysis in financial news. The improved in accuracy, precision, recall, and F1 score across all models confirm the importance of contextual embedding provided by BERT. These findings suggest that future research in sentiment analysis, particularly in domains like finance, should continue to explore and implement transformer-based models like BERT. Going forward, we plan to explore our transformer architecture and fine-tune our model further to improve their performance on even more challenging datasets. Coming to the end of our presentation, thank you for your attention, and we are happy for the opportunity that the journal gave us to share our work. Thank you once again.